We have already discussed public key cryptography from the standpoint of key generation and how those keys are used for secure communication. But we haven't talked about where the public keys are stored and how they are managed. That is the focus of this lecture as we cover the other side of the coin to public key cryptography. Public key cryptography was originally conceived in the 1970s by a British cryptographer who worked for a British intelligence service, but it didn't become known about publicly until several years later. The first web-based key server was created by an MIT student, and then the PGP organization created one at a later time and maintained it for many years, but they were acquired by Symantec in 2010, and now Symantec maintains those servers. It is interesting when publicly known companies take ownership of something such as this, because you immediately have to wonder if they have changed any of the code that generates the keys and whether or not any insecurities have been introduced. Using a key system that is open source and has the code available for anyone to review is generally considered a safer option. So the current state of this technology is that it continues to expand, and even though the methodology has basically stayed the same since the 1970s, it is being adopted more today as more people are starting to recognize the importance of securing their communication in an ever-growing digital world. Many servers exist around the world that publicly store the public keys used in this type of encryption. These servers hold millions of keys, and anyone with access to a public key server can acquire the public key of someone they want to communicate with. Oftentimes, organizations and people who communicate frequently with each other will agree to use the same public servers to make the process easier. And some organizations have set up their own public servers to make management of the keys a little easier as well. The availability of these key servers encourages encryption because providing a place for the public to store their keys greatly increases the chance that encryption will be used. And since most of the public servers are accessible from anywhere in the world, it also allows people to communicate securely from anywhere. This can be very beneficial for world travelers who are concerned about being spied on by other governments, or corporate travelers who want to protect sensitive business deals. And there are many public key servers that are free to use by individuals, so there are a lot of options in this arena, and for anyone who wants to use encryption, the possibilities are definitely available. Some organizations have taken the security of the public server construct even further by using a private server within their own networks to house the public keys. This creates a much smaller circle of communication, as it limits those who can securely communicate with each other to those who can access the key server. This is more common in government circles, specifically in isolated networks that already require some level of security clearance to access. The problem with this implementation is that if you want to communicate securely with someone who does not have access to this network, you would then have to have another set of keys on another network that actually uses a publicly accessible key server. With the security of the public key cryptography system, there is really no reason to hide the key server from the public. Closed off or isolated networks may be the only place where this should be implemented, simply because there is no other option. But for an organization to take these steps as a way to add security really doesn't make a lot of security sense. There is also the reality that having a key on a public server can reveal that you are encrypting information, and can reveal a small amount of personal information, but that seems to be negligible in comparison to keeping your data secure. There is one major advantage, however, to an organization maintaining their own public server. Oftentimes, keys can be uploaded to a public server and stay there for a very long time, because the process of removing it is not always an easy one. This can lead to a server full of unused keys or keys that have been expired, and it could make it difficult for someone to find the correct public key. Another problem with a publicly accessible key server is that since anyone can upload a key, someone could conceivably create a public key using someone else's name and then pretend to be that person. This could be beneficial in social engineering scams, so a level of protection needed to be added to the system to keep this from happening. Many of the public repositories have added an email verification process to help verify the owners of keys and keep any fake ones from being published. These organizations have also implemented a key renewal process that keeps keys from becoming outdated. So the implementation is not a perfect system, and even with a fairly simple encryption process, the management of the process can create some headaches along the way. If you do decide to create a set of keys, you will find that there are a few public servers used most often by private users of encryption. The first one on our list is housed on the GNU server. GNU, by the way, is basically part of many Linux operating system versions, and the GNU organization is super focused on free software and privacy, which is why they got involved in the encryption arena. Anyone can use the GNU server to publish their public keys and access other keys. The famous Massachusetts Institute of Technology, not surprising since it was one of their students who pioneered this concept, also maintains a public key server that anyone can use, as does the organization behind the Ubuntu Linux distribution. These are just a few publicly available key servers, and there are many more. The most important thing to consider when using one of these servers is uptime. There really is no risk with publishing a key, so as long as it is in a place that is consistently available, you should be good to go. Once it is published, you can share a link to the key on Facebook, on a business card, or even your own website, or anywhere else you feel someone may look for it. You could even create your key and only publish it on websites you control, but it makes more sense to use a key server and link to the key server from other locations. This way you only have to keep one location updated, and everything else will link there for your key. We have put a lot of discussion into this topic, and by now you should realize that the most important element to remember is that without encryption it is virtually impossible to have regular, secure communication. Any fan of the Survivor television show knows that the secrets passed between the contestants are often conducted far away from competitors, because the only way they can be sure no one is listening in is to go far away and whisper as quietly as possible. This method isn't feasible in most situations today, so being able to provide a publicly accessible way to create encrypted content is certainly a critical requirement. Proving that the person you are talking to is who they say they are is also important. As I mentioned earlier, I can publish a key for a name that isn't mine and make that key available in a lot of different places. But there are a few ways to allow identity verification. One is to create an X509 certificate that allows others to verify your identity. Another method is to create a hash, like we discussed in an earlier lecture, of your public key and provide that hash separately on a site that you control. Then any user who wants to verify your identity can check the hash and make sure it matches. Are there any workarounds? Sure. You can email your public key to people if you only securely communicate with a small audience. That's probably the most practical thing to do in small circles, but outside of that, the key server is really the best route to take. So now you have an understanding of how the key server system works, and you will have to decide for yourself if you want to use a public or private server configuration to store your public keys. You are also aware of some of the problems that can exist in using public key cryptography, but hopefully you have come to realize that the benefits far outweigh the potential problems. Public key cryptography really is as secure as people say, and the availability of these key servers make the system work much smoother. I personally use encryption for text messaging, some voice calls, and have also used it extensively within email systems. It's not really needed for everyday communication, which is why most people aren't using it. Encrypting a text message that asks someone to stop by the store for a gallon of milk isn't really important. But the technology can come in handy if the need for secrecy does arise. In fact, I wouldn't be surprised at all if at some point in the future, parents start issuing encryption keys to their kids to encrypt all of their communication so that predators cannot use this content for nefarious purposes. And protecting our kids is one area that we can't afford to let our guards down.